Now we will discuss about the speed of rotation of a synchronous machine. So the synchronous machine can only run at synchronous speed. So why is that? It is because of the DC field circuit. In the induction machine, we had 3-phase winding, right? And this 3-phase winding, currents were induced because of the currents in the stator winding, right? Currents induced due to transformer action. Now the magnetic field, the rotating magnetic field produced because of these currents is itself moving. Okay, RMF is produced due to rotor currents, and there is relative motion between the rotor RMF and rotor. But in the synchronous machine rotor, so this is the rotor we are talking about, you're going to have a DC winding, DC field circuit we have. So the currents are not produced due to transformer action. These are simply DC currents which are producing stationary magnetic field. Okay. So in the induction machine, the rotor currents are induced due to transformer action. Here the rotor current is due to external DC excitation. So what will be the magnetic field that is produced? It is a stationary magnetic field. Okay. Now we make this a rotating magnetic field by moving the rotor. Okay. So there is no relative motion between rotor RMF and the rotor. Okay. So whatever will be the speed of the rotor, that will be the speed of the RMF. Now we already know that the synchronous speed is given by 120 Fe by P, where Fe is electrical frequency of stator currents. So using this expression, we can see that in synchronous generator, if you are moving the rotor at synchronous speed, okay, that means at any particular speed n, if you are rotating, then the corresponding frequency you can get. Electrical frequency of generated power is Fe is equal to Np by 120, where N is the speed at which prime mover is rotated. So that means you have to understand here, if we want 50 Hertz frequency and the number of poles are given as say 4, then what should be the speed of rotation so that this value is 50 Hertz. That is what is the speed at which we make the prime mover to rotate. That is what happens in the synchronous generator because it is generating power. Now what happens in motor? In synchronous motor, we are going to give here the frequency is decided by us. It is pre-decided by us. So the speed with which the rotor will rotate will automatically be equal to 120 F by P. So here the speed of rotation is N is equal to 120 Fe by P, where Fe is usually we give it to be 50 Hertz. Okay. So you have to understand what are the parameters that we set here and what are the parameters that we are getting as a result. In synchronous generator, we are setting the speed so that we are getting the specific frequency, and in synchronous motor, we are giving a specific frequency and the specific speed is going to be according to this expression. So this point is important, that in an induction machine, the speed will never be synchronous speed. If it becomes synchronous speed, it will stop running. But in a synchronous machine, the synchronous motor, the speed is going to be only the synchronous speed. Okay.